Hello everyone. Today I thought we would talk a little bit about control structures, but mostly we're going to be talking about conditions and relational and logical operators. We'll start out with some simple review of control structures, if statements, while loops, that kind of thing. We'll do a short review of the syntax, and we'll talk about some of the pitfalls of control structures, such as putting a semicolon at the end of a condition. We'll talk about how for a loop, either the loop body or the condition of a loop must change the value of the condition at some point, otherwise the loop will be infinite. I'll say a few words about nesting, and we'll talk about controlling loops, sentinel control, counter control, and accumulator control. This stuff is in your book, and again, I'll just very briefly hit on this as we go along. But most of the time, we're going to be talking about conditions, which are expressions that resolve to a logical value or a Boolean value, true or false, and we'll be talking about how to get Boolean values and how to combine them, and relational operators and logical operators. There are three major ways to have a Boolean expression. One way is to just have a literal. Here, for Sophie, true is a Boolean value. It's a literal, like a 5 is an int literal, or putting something in double quotes is a string literal. Boolean is a primitive data type, like int and like double, and true and false are literal values, and every Boolean value has a true or false value. Another way that we can get a Boolean value is to call a method that returns a Boolean value, and we'll talk about that later on. I won't show that at the moment. And another way that we can have a Boolean value is that we combine the logical operators of and, or, and not, and possibly with some relational operators which return a Boolean value. And this will resolve to a Boolean value, kind of like adding two ints or adding two ints and then multiplying by a third int and dividing by a fourth int will resolve to an int value. We can do similar things with Boolean values. For example, I can take a relational operator, and greater than is a relational operator, and in this particular case, my Boolean variable, Jack will have to have a value true or false, will be false because the integer I is not greater than 5. In fact, it's equal to 5 from the declaration up there. A couple of points I want to make about this is we'll be going through all these logical and relational operators in more detail, but they will seem very simple, and that is in fact correct. They are very simple. Do not try to overthink these things. Do not try to overthink the control structures. The difficulty with control structures and with conditions in relational and logical operators comes in trying to combine them. I would say it's kind of like Lego bricks. A 3-year-old can put two Lego bricks together. Putting two Lego bricks together is not hard. It's both simple and easy. But when your 7-year-old brings you a picture of the Statue of Liberty made out of Lego and says, "Build this for me," that's where the difficulty comes in. Yes, Lego bricks and putting them together are very easy and simple, but constructing something as sophisticated as the Statue of Liberty out of Lego bricks is a very difficult task. And that's going to be the kind of challenge we face when we're doing conditions and using control structures and so forth. It's not that they're difficult or um, difficult to understand, it's the combining of them that's going to bring the challenge. So I'm going to stop this video here, and I suggest you bring up Eclipse and we will go down doing some programs together to explore conditions and relational operators and logical operators, which are also called Boolean operators, and a little bit about control structures. Be speaking with you in just a few minutes.